going to see polar plot, and polar plot means it is also a frequency response. It is also a frequency response. But it is plotted between modulus of G of j omega and angle of G of j omega. That is called polar plot, but plotted in a polar chart. Plotted in a polar chart. This is called polar chart. Its axes are 0, 90 degree, 180 degree, 270 degree, and 360 degree. Or you can say that minus 90 degree, minus 90 degree, minus 180 degree, minus 270 degree. If you see in clockwise direction, the angle is negative. If you saw in anti-clockwise direction, the angle is positive, that we know. Here, suppose you are having a transfer function g of s equal to 2 upon 5s plus 1. For that, if you want to draw frequency response on a polar chart, you have to find g of j omega, that is equal to 2 upon j omega 5 plus 1. If you g of j omega, modulus of g of j omega equal to 2 upon square root of 25 omega square plus 1. This is modulus of g of j omega. The angle of g of j omega is tan inverse of, here angle of 2 is 0. Angle of 2 is 0, and angle only for this denominator. That's why tan inverse of imaginary part divided by real part, that is 5 omega. That's all. Because of denominator minus tan inverse of 5 omega. That's all. If you plot between if you plot between modulus of g of j omega and angle of g of j omega in a polar chart, then it is called polar plot. Plot between magnitude of g of j omega and angle of g of j omega in a polar chart, then it is called polar plot. Now let us find the various coordinates for this given transfer function. If you find various magnitude g of j omega and the angle, you have to find both magnitude as well as angle. You have to find angle of g of j omega. Both you have to find. First, we have to find for omega equal to 0, and finally you have to find infinity, omega equal to infinity. If you substitute omega equal to 0 in the magnitude plot, you will get 2 is the answer. If omega equal to 0, what you will get 2 is the magnitude. Therefore, when omega equal to 0, 2 is the answer. When omega equal to 0, what is the angle? If you substitute omega equal to 0, the angle also 0. When omega equal to infinity, when omega tends to infinity, what you will get is, if you substitute 2 by infinity, that is equal to 0. Therefore, the magnitude is 0. Magnitude is 0. If you substitute omega equal to infinity, what you will get? Minus 90. So for various values, for omega equal to 1, we have to find various values for omega equal to 1, 10, 100, like that. What is the time constant? 5. 1 by 5 means 0.2 and 1 here. 0.2, 1, 5, 10, 100, 1000. Like that, you have to find various values. If you find what is the initial value when omega equal to 0, the magnitude is 2. The magnitude is 2. The magnitude is 2. Angle 0. Angle is 0. Finally, the magnitude is 0. Final value is magnitude is 0. Angle is minus 90. It means it approach at an angle minus 90 degree. It approach the origin at minus 90 degree. It starts at 2 and end at 0. This is the plot. A semicircle center at 1. It is a semicircle center at 1. Here, for various values, angle varies from 0 to minus 90. In between, you will get the angle between 0 and minus 90, and different magnitudes start with 2, end with 0. Therefore, this is the plot. This is the plot. This is the plot for given first order transfer function. This is the polar plot. Polar plot can also be called as Nyquist plot. Polar plot can also be called as Nyquist plot. Because what is polar plot? Actually, what we varied omega. In other words, we substituted j omega axis, the magnitude of j omega axis from 0 to infinity. Am I correct or not? We substituted the values of 0 to infinity here, and we find magnitude and angle we plotted. Similarly, we can substitute minus j infinity to 0 also. If you substitute like that, you will get a plot like this. You will get a plot like this. You will get a plot like this. And if you take a semicircle of radius infinity, its radius is infinity. Take a radius infinity. What is the magnitude? Infinity. If you substitute, what is the coordinate here? Suppose I am taking a coordinate here. What is the magnitude here? Infinity. What is the angle? 0. I am taking coordinate here. What is the magnitude? Infinity. What is the angle? Minus 90. Here I am taking one coordinate. Infinity. What is the angle? 90. If I select all these points, what are the points? One is from 0 to infinity in the positive imaginary axis. Magnitude of omega from 0 to infinity. Another one is from minus infinity to 0, negative imaginary axis, all omega values. I substituted in the transfer function. I got some values that is plotted means. Already I told you that it will be looking like this. In addition, you have to plot this also. Plot this also. Here, all values are infinity. Only angle is varying from plus 90 to minus 90. Angle is this semicircle. The angle is varied from plus 90 to 0, then 0 to minus 90. But magnitude is infinity only. If you substitute magnitude equal to infinity, what you will get? Always 0. Always 0. If you do that plot also, it is always at 0 only. But angle only varies. Angle only varies. Only angle varies, but anyhow, magnitude is 0. The dot, its angle is varying. That's all. The dot is rotating itself. That's all. It's a dot at origin. So, if you plot the magnitude and if you plot by substituting positive imaginary axis, negative imaginary axis, and semicircle of radius infinity in the transfer function and plot that response is called Nyquist plot. Nyquist plot. What is Nyquist plot? What is polar plot? If you substitute only positive imaginary axis, magnitude of positive imaginary axis in the transfer function, and if you got the plot, then it is called polar plot. If you plot for negative imaginary axis, magnitude of negative imaginary axis also, then you got the complete plot. The only pending is you have to draw this circle whose radius is infinity and the angle alone varied. That is nothing but a point at the origin. So if you combine all these three, then it is called Nyquist plot. Then it is called Nyquist plot. Then we can call polar plot also Nyquist plot because it is part of Nyquist plot. It is part of Nyquist plot. Why we are doing all these things, you'll see one by one. So this is polar plot for the given transfer function. This is the given transfer function. What is the order of the system? Order is 2. Type number 0. Am I correct or not? Type number 0. What is the magnitude of this magnitude? That is magnitude equal to modulus of G of j omega. That is equal to k upon square root of T1 square omega square plus 1 square root of T2 square omega square plus 1. This is the magnitude. What is angle? Angle of G of j omega. That is phi equal to angle of k is 0. What is the angle of this? Minus tan inverse of omega tau 1 divided by 1 minus tan inverse of omega tau 2 divided by 1. That's all. If you want to plot this, we have to find for various values. Angle and magnitude we have to get. To get the polar plot, we have to vary omega from 0 to infinity. You have to get modulus of G of j omega and angle of G of j omega that you have to find. If you substitute 0 here, what you will get? If you substitute 0 here, omega equal to 0, you will get 1. If you substitute omega equal to 0, you will get again 1. K by 1, therefore k you will get. Magnitude is k. Angle, omega equal to 0 means angle. This becomes 0. This is also becomes 0. Therefore, angle is 0. When omega equal to infinity, what you will get? This becomes infinity. K by infinity. This is also infinity. K by infinity, that's why 0. Magnitude is 0. Angle, for this you will get minus 90. For this you will get another minus 90. Therefore, minus 180. Minus 180. So, initial value is gain K. The final value is 0. So, for various values of omega, you have to get magnitude and angle. For that, if you plot, it starts at K with angle 0. K angle 0. The first value is K angle 0. The final value is 0, 180. It approaches the origin at an angle 180. So, what is the first order type 0 system? This is the plot. It approaches the origin at 90 degree. What is second order type 0 system? It starts here and end at 180. So, we can, if it is third order means you will get one more. If third order means you will get one more tan inverse of omega T3. That's why another minus 90. Therefore, if it is third order means the plot will be looking like this. It approaches the 0 at minus 270. Minus 270. It approaches the origin at minus 270. This is order 3 type 0. This is order 2 type 0. This is order 1 type 0. These are all type 0 systems. Start at open loop gain. Here, where it starts at 2. That is open loop gain. Here it starts at K. Open loop gain. Here also it starts at K angle 0. So we can draw the rough plot. We can draw the rough plot without knowing anything. We can draw easily. If you know the type number and order number, I can draw the rough frequency response without knowing anything. So I want to draw type 0 fourth order system. Type 0 fourth order system. It starts at K, open loop gain K. Third order ends here. Fourth order, where it will end here. This is the frequency response. Rough plot without mentioning the magnitude. That's all. So for a type 0 system, it starts at negative positive real axis, end at 0 at an angle 90, minus 90, at an angle minus 90 for first order, minus 180, end at minus 180 for second order, minus 270 for third order, minus 360 for fourth order. Suppose I am taking a type 1 system. This is type by seeing this plot, you can tell what is the order number. What is the order number? Type 0, order, third order. So by looking at the polar plot, we can tell the order and the type number. So suppose I am having a type 1 system. Type 1 system G of j omega. Hereafter, I won't write in S domain. Directly, I will write in frequency domain. K upon S, type 1 system. J omega j omega tau 1 plus 1, j omega tau 2 plus 1. What is the order? Order is 3. Type number is 1. Type 1, order 3. Am I correct or not? What is the degree of denominator? 3. Therefore, order 3. Type number is 1 because 1 S is there in the denominator. That's why type number is 1, order is 3. Here, let us find the magnitude, modulus of G of j omega, equal to what? K upon j omega. If you take modulus omega, square root of omega square T1 square plus 1, square root of omega square T2 square plus 1. That's all. What is angle? Angle of G of j omega equal to tan inverse of minus tan inverse of omega 1 T1 minus tan inverse of omega 2 T2 minus 90 degree. For j omega minus 90 because real part is 0. Tan inverse of imaginary part divided by real part. Real part is 0. That's why infinity. So minus 90. S means minus 90. So here, when omega equal to table, let us form the table to draw that polar plot. We have to form the table to draw the polar plot. Omega modulus of G of j omega and angle of G of j omega. First value we have to find for 0, then we have to find for infinity. For 0, what you will get? Substitute 0, anything by 0. This becomes 1. When omega equal to 0, this becomes 1. When omega equal to 0, this also becomes 1. When omega equal to 0, this becomes infinity. That's why magnitude is infinity. For type 1 system, magnitude is infinity. What happens to angle? Substitute here omega equal to 0. Substitute 0 here, you will get 0. 0 here, 0. But anyhow, you will get minus 90. Minus 90. When omega equal to 0. When omega equal to infinity, what you will get? If you substitute infinity, automatically it becomes 0. Magnitude is 0. Finally, it goes to infinity. Finally, it goes to origin. What is the angle? For this, when omega tends to infinity, this becomes minus 90. Tends to infinity, this becomes minus 90. So 270, angle is minus 270. 270. Angle is minus 270 degree. So what is the angle here? This is 0, minus 90, minus 180, minus 270, minus 270. It starts from omega equal to 0. It starts at infinity. When omega equal to 0, its magnitude is infinity. When omega equal to 0, its magnitude is infinity. Angle 90. That's why it is coming from 90. That's why it is coming from minus 90. It is coming from minus 90. It is coming from minus 90. Final angle is 270. Therefore, it ends at minus 270. Minus 270. That's all. So, by looking at the polar plot, you can tell that it is a third order system. Third order system. Type 1. Why type 1? It starts from minus 90. Why third order? Third order. Here also third order, where it ends at minus 270. Third order means it ends at minus 270. So the ending point tells the order. Starting point tells the type number. Type number. Suppose I am having a system G of j omega equal to k upon j omega multiplied by j omega t1 plus 1. What is the order? What is the order? Order third. Order 3. Type number 2. Let us form the table. If you form the table, omega modulus of g of j omega, angle of g of j omega. The first value is 0 and the final value is infinity. Here, the magnitude of g of j omega equal to k upon, for this omega, for this also omega. Therefore, omega square. Square root of omega square t1 square plus 1. If you substitute omega equal to 0, you will get magnitude is infinity. What is the angle? Angle of g of j omega equal to minus 90 for first one. For second one, again minus 90. For minus another s square, j omega multiplied by j omega. Minus tan inverse of omega tau 1. When omega equal to 0, you will get minus 180. Minus 180. When omega equal to infinity, you will get 270. 270 magnitude. If omega equal to infinity, you will get 0 magnitude. Always it ends at 0. But angle is different. Angle is 270. Third order. Third order means 270. But type 2, that's why it starts at 180. It is coming from 180 degree. Minus 180 degree. And end at 270. Type number 2, order 3. So by looking at the plot, we can tell the order number and type number. By looking at the plot, we can tell the order number and type number. This is called polar plot.